In this video, I am going to solve the problem 9 from chapter 26. A potential difference of 6 nanovolt is set up across 1.5 centimeter length of the copper wire that has the radius of 2 millimeter. How much charge drift through the cross section in 4.7 millisecond? So here we are going to find the value of the charge. So if you read the last line, how much charge drift through the cross section in 4.7 millisecond. So that means we are going to find the value of the charge. And also they mentioned the information about the time. Time t is equal to 4.7 millisecond. Milli takes the value of 4.7 multiply. Milli takes the value of 4 multiply 10 power minus 3 second. And also they mentioned the information about the potential difference. V is equal to 6 nanovolt, which is 6 multiply 10 power minus 9 volt. And also the length of the wire here mentioned as 1.5 centimeter in terms of meter is 1.5 multiply 10 power minus 2 meter. And also the radius of the wire cross section is given here as 2 millimeter, which is 2 multiply 10 power minus 3 meter. So here for calculating the value of the charge, we need the cross-sectional area of the wire. So first of all, I'm going to calculate the area. As we know, the cross-sectional area of the wire is like an area of the circle. So we know the formula for the area of the circle, which is pi r square, right? So I'm going to calculate the area here by using the radius. Therefore, area is equal to pi multiplied by the radius here is 2 multiply 10 power minus 3 the whole square. I got the area here as 1.26 multiply 10 power minus 5 meter square. And also the material of the wire mentioned here as copper. We need the resistivity of the wire of the copper, right? So the resistivity of the copper wire takes the value of 1.69, which is a constant, 1.69 multiply 10 power minus 8 ohm meter, because we need this value for calculating the value of the charge. Okay, now I'm going to solve the question. We are going to find the value of the charge. So first of all, I'm going to write the formula for calculating the charge. In theory, we studied the rule for calculating the charge. Q is equal to the current multiplied by time, right? If you see this rule, we have the value of the time, but we don't have the information about the current. So for that, I'm going to use the Ohm's law. V is equal to IR. Therefore, current I is equal to V over R. So what I'm going to do, I'm going to substitute this value of this current here. If you substitute, what will happen? This formula is equal to, that means the charge Q is equal to V over R multiplied by the time T. And now you have to see here, after you substitute this value here, we got this rule Q, which is equal to V over R multiplied by T. Potential is already given in the question, but we need the information about the resistance, and I'm going to use the formula for the resistance. R is equal to rho L over A. So if you take this R, if you substitute the value of this R here, this formula will become Q is equal to VT over rho multiplied by L over A, and this A will go to the top. By that, this equation will become Q is equal to VTA over rho multiplied by L. What is this? V stands for the potential, V, okay, and T stands for the time, and A is the area of the cross section of the wire, and rho is the resistivity of the copper material, and L is the length. Now we have all the information. So now what I'm going to do, I'm going to substitute the value. So what is the value of this potential? Potential is 6 nanovolts. That means 6 multiplied by 10 power minus 9, and the time is 4.7 millisecond, which is given in the question. So 4.7 multiply 10 power minus 3, because milli you have to convert it in terms of 10 to the power of 3, because milli takes the value of 10 to the power of minus 3. And area, we already found the value of the area here as 1.26 multiply 10 power minus 5. So I'm going to use that value here. Multiply 1.26 multiply 10 power minus 5 over the resistivity of the copper is a constant 1.69 multiply 10 power minus 8, and the length of the wire is 1.5 centimeter. So after you convert the centimeter to meter, which is 1.5 multiply 10 power minus 2, if you calculate this, we got the charge information as 1.4 multiply 10 power minus 6 coulomb. So this many charges drift through that cross section in 4.7 milliseconds. So this is the answer for this question. That's it. Thank you.